Welcome to this review of the NFPA 13 Code Questions for Sprinkler Fitting Level 4. We'll be going through the written question review answer key, covering various chapters and key concepts to challenge and reinforce your code skills. Let's start with Chapter 3, which focuses on definitions. A common question is what makes a quick response head desirable over a standard response sprinkler? The key is its more sensitive element. This means water is discharged sooner on a typical fire in a light hazard environment. Because it reacts faster, it can maintain control of the fire with fewer sprinklers opening, which ultimately results in lesser water supply requirements. Another important definition is that of a small room. According to Section 3.3.22, 3 factors must be met. It must be a light hazard occupancy, it must be 800 square feet or less, and it must have unobstructed construction. Additionally, it must be a compartment. Looking at a typical building elevation diagram, it's crucial to identify the various components of a sprinkler system. A represents the system riser, the vertical pipe supplying the system. B is the branch line, where the sprinklers are directly attached. C is the cross main, which feeds the branch lines. D is the riser lipple, connecting the cross main to the branch line. E is the feed main, supplying the cross mains. And F is the underground supply. Moving to Chapter 5, we look at the classification of occupancies and commodities. When classifying a particular commodity, you must consider the individual makeup of the storage units and relevant test data. For example, a Class 1 commodity typically consists of non-combustible products stored on wood pallets, in cardboard cartons, or wrapped in paper or plastic. In Chapter 6, we cover system components. For light hazard occupancies, if you're using sprinklers with orifices smaller than 3/8 inch, a strainer must be installed on the supply side. Also, it's important to know how temperature ratings are indicated on coded heads. This can be done with a colored dot on top of the deflector, colored frame arms, or the color of the coating itself. Chapter 7 deals with system requirements. When using 2 or more dry valves, the system should be divided horizontally. This prevents the simultaneous filling of 2 dry systems if a fire occurs on a boundary. For dry systems exceeding 750 gallons, the system must deliver water within 60 seconds, or meet the specific times stated in the water delivery table. A key advantage of using nitrogen instead of air in a dry system is that nitrogen is dry, which significantly reduces corrosion. Chapter 8 covers installation requirements. The 3 basic principles for spacing and locating sprinklers are: they must be installed throughout the premises, they must not exceed their maximum coverage areas, and they must be positioned so that heat collection and activation can occur properly while minimizing obstructions to the discharge pattern. Also, note that for early suppression fast response, or ESFR sprinklers, the maximum allowable ceiling or roof slope is 2 and 12, or 16.7%. In Chapter 9, we discuss hanging and restraint. A critical rule is the hanger load requirement. Hangers must be able to support 5 times the weight of the water-filled pipe, plus an additional 250 pounds. When using post-installed anchors on concrete beams, they must be located above the center of the beam and above the bottom rebar. For risers, sway bracing requires a 4-way brace at the top within 24 inches, with subsequent braces spaced no more than 25 feet apart. Chapter 10 covers private underground fire service. During a hydrostatic acceptance test for underground piping, the minimum required pressure is 200 psi. When measuring the depth of covering for buried pipe, always measure from the top of the pipe to the finished grade. And remember, during pressure acceptance tests, the allowable leakage is 2 quarts per hour per 100 joints. Chapter 11 focuses on design approaches. When classifying an occupancy, 5 main criteria are considered: the quantity and combustibility of the contents, the expected rates of heat release, the total potential for energy release, the heights of any stockpiles, and the presence of flammable liquids. These factors determine the hazard level and the corresponding system design requirements. In Chapter 22, we look at plans and calculations. Hydraulic calculations always begin at the most hydraulically remote sprinkler in the system. The Hayes-Williams formula is used to calculate friction loss. Regardless of the design, the minimum operating pressure for any standard sprinkler is 7 psi. Also, remember the Hayes-Williams C values for black steel pipe, 120 for wet systems and 100 for dry systems, reflecting the increased internal roughness in dry pipes. Finally, Chapter 24 covers system acceptance. The piping between the exterior fire department connection and the check valve must be tested in the same manner as the rest of the system. When hydrostatically testing dry systems, the clapper must be held off its seat, unless the valve is specifically listed for testing while sealed. And always place the pressure gauge at the lowest point of the system during a hydrostatic test to ensure the highest pressure is recorded. To wrap up, mastering the NFPA 13 code requires a solid understanding of definitions, component functions, and occupancy classifications. You must strictly follow installation, hanging, and bracing requirements and adhere to all testing and acceptance protocols to ensure a safe and compliant sprinkler system. Keep reviewing these key concepts to strengthen your code skills.